Sir, Sridhar sir, YouTube link.
స్టార్ట్ చేశారు సార్ ఇప్పుడే స్ట్రీమింగ్
చేశారా అంటే అది పెట్టారా?
పెట్టారు. ఒక లింక్ కాపీ చేస్తుంది.
ఓకే.
Shall I share the screen or wait? Somebody raise your hand. Saravanan sir, anybody?
Single server, sir.
Somebody raise your hand.
Okay, sir. Okay, sir. We will check it, sir.
Yeah.
Single server, sir.
Sir.
Sir, Muthulakshmi madam raise the hand. Sir, check it, sir.
I request the participants, if you have anything to say, please post in the chat box. One of the participants, Muthulakshmi D. Ma'am, if you have any doubt, please post in the chat box, ma'am, so that we can see it. So session will start in a minute, sir. So YouTube is on live. So we will start in few seconds. Shravan sir. Shravan sir.
Hello, sir. Good evening, sir.
Yes, sir. It's time now.
Okay, sir.
Everything okay, sir.
Okay, sir. Thank you, sir. Good evening to everyone.
Hello, sir.
Madam, Sutleka, madam, start cheyandi, madam. Yes,
Okay,
madam.
sir.
Yes, madam.
Okay, sir. I'll start. Good afternoon to the academicians from various colleges and dear participants. We hope the previous session feels great simplicity in our insight. And today's session will be extend us towards research challenges in electric vehicles by Honorable Speaker Dr. Ramarao sir. It is my significant privilege and joy to introduce today's speaker, Dr. Ramarao Pokanti. Sir is working as Professor and Dean R&D Department in EEE Department, Sri Vasavi Engineering College, Tadepalli Gudam, Andhra Pradesh. He obtained doctoral degree in electrical engineering and Master of Technology in Electrical Power Systems and Bachelor of Technology in EEE from in 2012 and 2006 and 1998 respectively. Sir is educating the students over 20 years. Besides handling various designations includes ad hoc lecturer, assistant professor, associate professor to professor, head of the department EEE, dean for R&D department, and NBA and NAC coordinator, BOS member, academic council member, governing body member, etc. Sir refereed 40 international journals and 59 international and national conferences. He presented 12 guest lectures. He holds the various professional body memberships in ISTE, Institute of Engineers India, IUCEE, World Academy of Science and Engineering Technology, World Scientific Engineering Academy and Society, International Association of Engineers, and member in International Society for Development and Sustainability, and also senior member in Institution of Electrical and Electronics Engineers. He organized 3 national conferences, Emerging Trends in Engineering, in the year 2014, 15, and 2016, and elected as a electrical division member during the period 2017 to 19 by the Institution of Engineering, India, Andhra Pradesh State Center. He is the editor-in-chief of iManager's Journal on Circuits and Systems and reviewer for few international journals and conferences, acted as a chair for one session in international conferences organized by Conferences World in the year 2016 and KL University in the same year. For his excellence in the electrical engineering area, Venus International Foundation honored him with Young Leader Award in the year 2019. He filed 2 patents and 1 patent is published. In the last 5 years, Dr. Ramarao sir bagged 8 external funded projects from the reputed agencies like Department of Science and Technology, Government of India, AICTE, APPSSDC, and MSME. Today, we feel lucky enough to take the session from Dr. Ramarao sir, and sir will have always been amazed by his ability to make even the most complex concepts understandable. It is such an honor for us to have Dr. Ramarao sir today with us. Thank you so much, sir, for coming and bestowing us with your own presence. Please welcome Dr. Ramarao sir today to start the session. Over to you, sir.
Yeah. Thank you, organizing committee, and especially Sri Lanka madam. Thank you for introducing me. Am I audible? Is it okay? The audio
Yes,
is
sir.
okay?
Yes, sir. Yes, sir.
Yeah, now I'll start my screen. It's already 4:35, I think. So just let's make it the presentation. Got it?
Yes, sir.
Yeah. So then it is cautioning my network is somewhat poor and low, something like that. So maybe I'll switch on and switch off the video. I think video is not the main criteria for our session. I think the presentation on the knowledge and information may be the first and foremost important thing. And so coming to the research challenges in electric vehicles, always electric vehicles we are hearing from the past years, something like electrical engineers we know very well, and we are familiar with this two words, electric and vehicles, electric plus vehicles. So electricity, okay, maybe value addition to the vehicles, so that it may become electric vehicle, something like that. And we are hearing now and then, some of the old vehicles are getting changed into electric vehicles by our good old technicians, good technicians actually on the outside. Actually, I am hearing so many messages through Facebook and WhatsApp and some social media, here and there, throughout our nation in many states. Actually, the technicians themselves are changing, some of the parts and replacing, the engine, something like, and converting the fuel, the fuel based vehicle or engine based vehicle, the four stroke acoustic, something like that, as well, two wheelers as well as four wheelers. We are seeing, here and there in the newspapers also we are seeing that the news. Students, most of them, especially in our country, seeing that in the papers and in the literature, in the okay, competitions or project exhibitions, something like that. We are seeing the electric vehicles. Just from the past 3 years or 4 years or 5 years, maybe I can say that. Okay, we are seeing the electric vehicles, only few electric vehicles on the roads, especially in some of the towns. Major towns, of course, from the past 5 years, okay, moderately we are seeing the electric vehicles, but in most of the towns in our nation, we are seeing that less density of electric vehicles. So, because of all this, okay, only we are limited to this literature, or limited to project exhibitions, or limited to project competitions, or limited to literature, something like that. So that's what actually maybe there are some challenges or some issues. So that is why people are still we are not finding much density of electric vehicles on the Indian roads. So what are the research challenges? Okay, coming to the research challenges. Okay, before going to see that research challenges, okay, what we can focus. Actually, what is the combination of electric vehicle, or what is the composition or configuration of electric vehicle? Maybe a drive. Okay, maybe a drive. So you can say that the drive. Okay, here you can see electric vehicle some diagram, and then you can see this one like so drive, electric drive system, and then battery. These are the two major components, or what we can say that major components coming to the electric vehicle. So maybe this is the technology what we have to say, or this is the most particular technology or most relevant technology to electrical and electronics engineering. Okay, that's what we have to see. And then maybe mechanical point of view and some technical areas we have to think of. Vehicle weight reduction, something like that, body, chassis, interior. Okay. Then some components and compounding weight. Okay. So those things actually we have to think of. So then that is what actually major part. And see, if you want to see this one, electric vehicle everywhere. Suppose you want to see electric vehicle everywhere. Okay, so electric vehicle everywhere, then you need to focus on technology. That you have to give a push to the technology R&D. Then so you have to enable the charging and enable for electric vehicle everywhere. Then market full, of course, the consumer acceptance. That means you have to make the consumer acceptance. Okay, so then only it goes to market. Okay, so that's what EV. Okay, you want to bring EV everywhere, then you have to see that. Okay, so this one. So then so coming to the challenges. And before going to see, still the types of challenges are different challenges. So I told you already. So there is some little growth in our density of the vehicles moving, electric vehicles moving around the India, or on the roads, something like that. So two-wheelers, if you see that two-wheelers, only around 3.5 to 4 million vehicles only they are moving. Okay, this is what. So two-wheelers, electric two-wheelers is only 0.2 million, or maybe up to 0.5 million nowadays. This 2 years back, a few thousand electric cars, something like that. Okay, so minuscule compared to the overall automotive fleet in India. That's what actually everyone can witness. Okay, so how the current situation in India about electric vehicles, or mobility of electric vehicles. Then so the economy-wide interactions among various sectors and stakeholders. If you look into the interactions, among various sectors and stakeholders, where you have got different stakeholders: battery manufacturers, and operation, power and utilities, oil and gas consumers, then government and regulators. All these are all various sectors and stakeholders connected to electric vehicles. Of course, government always be there, and on the other side, power because electric vehicle, and on the other side, battery manufacturers and EVSC electric vehicle supply equipment. Okay, so that's what actually. So people are there, and so the what is the access and what are the interconnections? You can see that. Okay, for subsidized tariff, discom losses, etc. There will be interaction. Okay, among the consumers, power and utilities, government and regulations. Okay, like that. So you can see here the interactions in the slide. Of course, there is nothing much difficulty in understanding the interactions among various sectors and stakeholders economy wide. Okay, from this image, depicted image. Then what is the impact of EVs on automotive supply and chain? Maybe some good impact, some bad impact, some neutral impact. So maybe neutral impact, okay, one can think of there is neutral impact okay, on this one, actually, especially, okay, neutral impact on components and systems, components and services, components and services, okay. So here components like air conditioners, braking system, both vehicles fuel based or even electric vehicles. Again, both vehicles both are required so that there is neutral impact of this accessories, lights, etc. There's good impact on components and consumables, especially batteries and motor controllers, cooling systems, chargers, microprocessors, and motors, DC to DC converters, some power electronic equipment, or some conversion system or drive system. Okay, along with control and accessories, microprocessors and all. Then wires and plugs. Okay, then services is also there. Maybe good impact on battery replacement and charging network operators. Okay, electric component or services. So there may be this one, and there's a bad impact on the components of engine, fuel tank, gearbox, because all these things are to be replaced in electric vehicles or plug-in electric vehicles or to some extent consumables, oil and lubricants, filters, there is some bad impact, and services, unorganized services and service stations like that. Okay, so this is what actually my point, the impact of EVs on automotive supply or automotive fleet. Okay, then move on to impact on power quality. This slide or this picture will clearly tell you, will clearly help you in understanding what is the impact of power quality. Okay, so hope I am audible to everybody. Okay, so if any questions are there, maybe after 45 minutes or 40 minutes, something like that, you can pause and you can go to few questions, and then later at the end of the presentation, you can go to the other questions. Okay, time permits. Then so this is what actually our maybe being electrical and electronics engineers and allied fields and other allied fields. So this is of somewhat interesting. To what you call do some to pursue some research or do some project work or to find to file a patent or to find a new product. There are lots of gaps actually. When I attended one of the conference in VR Siddhartha as a technical chair, in one session, my co-chair is electric vehicle expert actually. He is expert. He is working with KPIT, Tesla electric vehicle system in Germany. So that's what he told. There are so many areas where industry is looking for the development, actually product development, maybe major product or minor product, what we can say. Even the plug, even some kind of plug which will avoid short circuit while the charging the electric vehicle. Like that, actually he told several things actually at the time of during his presentation. Keynote so just this year only in the month of January. So that's what actually there are people there. There's industry is looking for lot of development tools areas actually they're expecting. And then, so maybe it is of more interesting for the power engineers especially. So, power electronics as well as power systems or power engineering. So, when you are connecting multiple electric vehicles, okay, individual EV slots, something like that, or all together at same slot, or partial number of, okay, some number of, okay, major number or minor number, something like that. When you are individual vehicles come back, okay, to the house in the evening, most of the, because they are employed or as well as in industry professionals also. Okay, mostly they will come back at 6 o'clock, 6 to 8, something like that. Okay, and suppose it is a city, something like that, they will come back to the apartments or gated communities, or they will go back to their residential areas. So then, if they start charging their electric vehicles at a time, something like that, all the vehicles at a time in a particular area or the total entire city, something like that, then see that, okay, what is its impact on power quality. So this is what actually where, okay, practically you need to study. Of course, we are doing simulations. Okay, we are building some models in the MATLAB and other simulation platforms, and we are analyzing. Okay, what is the distorted current? What is the distorted voltage? One vehicle, okay, is operated at so and so time, or for during this time 6 to 9 p.m. or some having some slots, and understanding the impact, or what is the analyzing the impact, something like that, distorted current or voltage or harmonics, something like that. Then, if it comes to electric grid, okay, what is SAG? Okay, because it's a grid, okay, so you are connecting, okay, electric vehicle, maybe some nonlinear load or power electronic equipment, something like that, you are connecting, okay, directly connecting to the electric grid through charging infrastructure. Then, okay, what is the thing? Okay, that's what actually. I think my voice is breaking. People are still I am
Yes, sir. Yes,
trying.
sir.
Okay, I'm trying. Yeah, I'm trying my level best, because all because of okay, somewhat network, okay, bandwidth, something like that. But still I'm trying. Here, now better, sir. Okay, thanks. That's what actually the impact. That's what actually the people who are pursuing research are okay, doing MTech. Okay, so think of, okay, one can think of harmonics reduction, or study the THD, distorted current, distorted voltage, and how can we reduce the distance? See, we are leaving at the just simply analyzing the THD or okay, voltage distortion or current distortion. That's all. Just we are doing a project, simulation project or hardware project, something like that. We are analyzing the harmonics and we are leaving. That is not that industry is expecting. Industry is expecting that, okay, analysis people, there are major sector actually. There are many people who can analyze, okay, with the help of either simulation tools or practically they can analyze. But what is next? Okay, that is what is very much important. Then the sags, well, etc. Then voltage imbalance. Okay, so the network balance. How do you create network balance? That is also important. Okay, electrical grid. How do you, okay, balance it? That is also important. Then, so flickers, okay, maybe, okay, flicker, tags, well, these are all voltage fluctuations. So what are the fluctuations? Then transformer overloading, one more thing actually. So in a particular region, in a particular area, okay, so what is the transformer overloading? Because this will not appear, the total electric vehicles node will not appear throughout the 24 hours, or okay, throughout the 24 by, okay, 365 or 24 by 30 by 365, something like that. It is not like that. Okay, so now and then it is appearing and it's on and off, something like that. So that is why, so we cannot, okay, change simply transformer. Okay, we cannot keep overrating or bulk rating transformer because of, okay, fraction of hour, because of some hours only, few hours only. Okay, the overload, something like that. Then what is the criteria? So how the transformer gets affected, or what is the impact, okay, on the transformer? So like that, okay, you have to study and you have to choose some remedies. Actually, you have to give some remedies. That is what all people are expecting. Industry people are expecting. Then developer perspective, what are the challenges of electric vehicles? So these are all challenges of electric vehicles from the developer perspective, especially manufacturing, something like that. then customer perspective, what are the challenges? Okay, we have to think of. Then okay, limited range, large battery size, battery life, maintenance, long charge time, time wastage, consumer acceptance, and the performance comparison or something like that. High initial cost, what is the return of investment? Then grid integration, where how to direct more energy to cater for increasing electric vehicle sales. So these are all developer perspective. And now I am coming to the challenges of electric vehicles. Maybe this is what actually our title of the webinar, this today's webinar talk under this research challenges in power electronics and power systems. Yes, that's okay. Maybe you can divide okay the challenges into four categories. One can usually if a product is there, okay, then so these type of categories comes under a product. So technical challenges, first category, that is what actually we have to look upon. This is what actually we have to study. This is what we have to find some okay uh, criteria okay to make it the best or better or optimistic, economical, something like that. So technical because we are more okay concerned with the technical challenges. Then infrastructure challenges, maybe to some extent we have to think of the infrastructure challenges also, because it is particularly relevant to electric vehicles and charging infrastructure mostly, other rather than servicing and okay maintenance, etc. Maintenance of course is also electrical aspect. uh, so infrastructure from maintenance point of view, servicing point of view, repair point of view, okay, as well as most importantly charging point of view, charging infrastructure. So charging along with safety, security, okay, those things. So maybe these two, okay, what I have to say, uh, more uh, relevant to our electrical okay part. So that's what okay technical and infrastructure. Okay, that's what actually we have to think of. Okay. So what actually we have to think of. So charging infrastructure. Then market, of course, testing, servicing, high capital cost, consumer perception, then policy. So policy mostly we are no way concerned, but if you are there in government regulation facilities and all, when we are working with government organizations, government bodies and facilities and all, then you need to involve in the tariff, taxation, issues and all. So that is what actually these are the challenges what we are going to discuss. Especially these two only. My point is to discuss technical and then infrastructure. Okay, so maybe I'm not the right person to discuss the challenges under market category and policy category. To some extent, lightly we can touch upon those 2 points also. So now coming to the okay technical challenges. Yeah. Yes. Okay. This is what actually thing is. So technical challenges. So what are the when it comes to technical challenges? What are the technical components? Something like that. What are the uh, components involved in technically? Means what are the various parts, configuration, composition? Okay, so the circuit. What is the circuitry and all? So when it comes to circuitry, okay, major portion or major cost, okay, that people okay are just okay one can understand. So motor, okay, so this is what motor. So then okay battery. That's what I told you in the beginning itself, the second slide, my title slide. So this what then remaining this what charging infrastructure coordination. Then technically maybe car body because of weight reduction, etc. Okay, collision safety and all. So car body you need to take. Then safety, maximize energy regeneration. So because okay, regenerative braking, something like that. Then drive system to run the drive and all in motor, low loss and okay less size, okay, and efficient inverter, something like that. Conversion, major portion to be converted. The output should be more 90%, 92% like that. Then electromagnetic compatibility, that is also important. Okay, these are. Then of course air conditioning, because this is also somewhat relevant to energy conservation and all. So that energy saving or heating, something like that. That's what. So these are the technical challenges what we come across in electric vehicle development. So battery development is the foremost technical challenge. Here it is underlined and highlighted. So battery development is the foremost technical challenge. That's what actually people are why going back from the electric vehicles, why they are not coming forward, okay, to uh, use use electric vehicles. That's what. Okay. So here, among other EV specific challenges, so battery development, battery design, battery packing. There are many sub areas, actually subcategories under battery development. We'll move on to the each category. First, electric drive system. What are the challenges with the electric drive system? Okay, the drive system means like motor along with some controller and some okay, maybe speed and direction controller, okay, torque control and all, with some inverter and conversion system. That's what actually. So of course, technology is advancing like anything, and with the advanced technology, especially power electronics and power electronic applications in power systems in, and many areas and many other areas are highlighted fields. Okay, we need to think of some advancements for electric drive system. Okay, to make the electric vehicle mobility everywhere. That's what electric mobility everywhere or electric vehicle mobility everywhere. Okay, you need to think of okay the what you call this one. This is also important. Okay, so here these are the four issues maybe have to think of. 4x, 4 times cost reduction, 35% okay size reduction, 40% weight reduction, 40% loss reduction by the year comes okay 2022 or 2025, something like that. So present electric drive system is almost costing per kilowatt $30, something like that. $30 we can imagine okay per kilowatt. If it is okay 20 what you call if it is 20, I think can somebody. So if it is 20 kilowatt, then 20 kilowatt in okay, so $30, or let us say 50 kilowatt per round figure, 50 into $30 per kilowatt. And how much? So 50 and 100 into rupees. Suppose if you convert into rupees, let us say 80 rupees. Exactly, I'm just only rough figure and calculate. Okay, 120 and 1,20,000 watt cost. It is 50 kilowatt. Suppose it is 50 kilowatt watt. Then 1,20,000. And suppose you want to see that 1.1 kilowatt per kg and 2.6 kilowatt per liter. Okay, so 90% system efficiency. Then all these features may cost you more. Okay, maybe 2 lakhs or again 1 lakh or something like that. Suppose it is 2 lakhs, then it is coming around okay around 3.5 lakhs, something like that. So this is what actually motor cost itself, that is drive system cost itself. Okay, around this is what here it is given 55 kilowatt system cost. Okay, $1,068. Today's electric drive system uses discrete components, silicon semiconductors, and rare earth water magnets. So these rare earth water magnets are costlier, and silicon semiconductors are costlier. Discrete components are costlier. So like for drive system itself, drive system alone 3.5 lakhs means other components. What is the battery? What is okay, body chassis? Okay, and okay air conditioning system. Okay, all those things. Then okay, the other accessories, something like that. So you can think of okay. So that's what actually then you have to think of to reduce at least 4 times the cost, that is $8 per kilowatt, and 35% size reduction from 1.1 kilowatt to 1.4 kilowatt, like that. Then 4 kilowatt per liter, like that. 94% efficiency, 40% loss reduction means 40% increase, 4% increase in loss efficiency, system efficiency. Like. So then it becomes 55 kilowatt system cost if you make it like that. If you focus and if you bring some advancements, some technology, okay, latest technology into the electric vehicles, okay, especially into electric drive system, then it reduces. So this is one challenge actually we have to think of by avoiding rare earth magnets, non-rare earth magnets. So shall we go for rare earth magnets? That's what rare earth magnets. What? And here I am showing what here. Okay, non-rare earth magnetic motors. Then integrating motors and electronics. Then wide band gap semiconductors instead of silicon semiconductors and rare earth magnets. If you bring in, okay, or one can bring in, one brings non-rare earth magnetic motors, integrating motors with electronics and wide band, wide gap semiconductors. Then okay, maybe so these things might be possible. Maybe possible these things. That is. Okay. Then, so how one can accelerate the development of advanced power electronics and electric motors, okay, for making the penetration of plug-in electric vehicles into the large market, or making a large enable the large market penetration of EVs. You can think of electric motors. Okay, that's what electric motors. So here, okay, this one. So low cost and high efficient motors. See, there are motors, there are efficient motors, but still, even you increase 1% efficiency, maybe that reduces the cost and reduces the loss and burden on the utilities and saves energy. Then alternative magnetic materials with the reduced rare earth content, like and improved motor manufacturing, improved manufacturing methods also. Okay, because motor manufacturing does not cause a burden to the electric drive system research and all. Then see, I told you already, accelerate the development of power electronics. So that means develop affordable wide band gap devices. That's what the previous slide also. Then high temperature capacitors or storage, large storage. Okay, advanced packaging. See, the battery you are using, of course, okay, and if you are able to save, okay, energy storage for high temperature capacity, high voltage operation, and new circuit topologies, so it will reduce the cost of the and weight of the weight reduction and all. So also include thermal management such as low cost heat transfer technologies and thermal stress and reliability and thermal system integration. So that will that will reduce the accessories cost and all. Then integrate the power electronics and motor technologies, like integrating the controller and inverter, drive system, total drive system, along with the integrated design and thermal management. Then onboard charges, so which reduce the cost on cost of charging, followed by overcoming package and thermal linkage. Even package, actually, industry is looking for package, innovative package. That is also one more thing, actually, one more important area. So think of an R&D point challenge. Then coming to the battery challenge, the next part is battery challenges. So even battery also, actually nowadays, why I told you already, why people are going back or putting back leg while to go for purchasing the electric vehicles. So that's what actually why the people are not interested. Why people are thinking number of times. They're thinking number of times. So to buy electric vehicle, especially battery maintenance, battery cost. If you want to replace, maybe the first battery, the battery comes with new car, maybe 5 years or 6 years like that. People are saying now, of course, 10 years batteries like that they are coming into market. But if it is 5 years, 6 years, then after 5 years, then we are paying charging cost as well as battery replacement time. These are all actually battery technology. You have to make some advancement or something like cost reduction, size reduction. Okay, all these features you have to bring in. Okay, that's what. So this is what actually. So cost reduction 4 times, size reduction 2 times, weight reduction 2 plus. Okay, more than 2 times like that actually getting off. So this is what battery technology now available. Maybe 2020, 2015, something like that. Okay, we have got it. Okay, this is the technology. So $500 per kilowatt hour. And lithium-ion batteries. Today's electric drive vehicles mostly, and combination of they are using combination of positive activities based on nickel, manganese or iron matched with a carbon or a graphite negative electrode. Maybe positive electrode, positive active material, positive electrode, the combination iron or nickel matched with a carbon or graphite negative electrode. Like what actually the today's battery technology, and so if we reduce the cost, size and weight, okay, then it may become $125 per kilowatt hour, something like that. So for motor, here we'll see that 50 kilowatt motor. Okay, uh, suppose you are using a drive. Suppose let us say 2 hours drive. Okay, 2 hours drive you are, or let us say 4 hours, 2 hours on and 2 hours onward journey, 2 hours return journey, something like that. 2 hours. Okay, 4 hours. Okay, you are driving this vehicle in a city to attend our our job or to perform our duties. All. So this is what actually 200 kilowatt hours actually. 200 kilowatt hours here. Per kilowatt hour $500 per kilowatt hour $500, then 200 kilowatt hours means 200 into $500. Imagine how much cost. Even you reduce this, okay, suppose only 1 hour, okay, let us say it is 50 kilowatt hour. Then imagine what is the battery cost, okay. But by 50 kilowatt hours, 50 into 500, that is 50 into 500 means 25,000. So 25,000 into 80 rupees, like imagine what cost. So this is what actually things are taking place. If you reduce the battery cost, then the penetration of plug-in electric vehicles or electric vehicles will increase. The market will increase, and the people will buy. Okay, so new battery technology. That means you have to bring in the advancements in such a way that what we call new concepts of lithium-ion technologies to double the performance and significantly reduce the cost. Beyond lithium-ion technologies, maybe lithium metal, lithium sulfur, and lithium air. Okay, like that. Actually, lithium-ion. Okay, lithium-ion. But beyond lithium-ion, suppose we have any, then think of. Okay, so this is what actually battery challenges. So better, we have to bring in some advancements in the battery that will enable the market penetration of electric vehicles. Not only battery electric vehicles, even plug-in electric vehicles. Of course, lithium ion, nickel, cadmium, and all we are using most of the time. But lithium ion is the young technology. It has changed the way we are using the battery devices. So that there is an opportunity for innovation that is also significant. And if you make the already, and they are expecting that package battery packet, optimization and simplification, then manufacturing, okay, then uh, material used for battery or for packing or okay cell level or pack level. Then okay thermal management technologies like that. Okay, this is what actually one has to think of. Okay, then high battery power density like 2000 watts per kg is important to meet the discharge power requirements for a wide range of PEV architectures plug-in electric vehicles to enable the battery to be rapidly charged or fast charging. Nowadays, actually, people are even fast charging, Wi-Fi charging, wireless charging, and all. Okay, it's important for consumer point of view. So these are all actually so battery challenges. If you overcome these battery challenges by bringing some young technologies or innovative technologies or simplified technologies or optimistic design, then people really come forward. Okay, so take up. And challenges associated with characterizing the cathode materials of especially lithium-ion batteries for vehicle applications. These are the challenges: reaction under far from equilibrium conditions, and power and safety. So maybe complexities at multiple scales, atomic, grain, particle, electrode. These are the insights actually one can see that. I'm not going into details, but these are the challenges actually associated with the cathode materials of lithium-ion battery. So you have to think of actually advanced technologies beyond lithium-ion technologies. That's what actually you have to think of. So here I told you already. So beyond, okay, this one. So beyond lithium-ion, okay, like lithium metal, lithium sulfur, okay, lithium air, okay, like that. So this is what we have to think of beyond okay, existing technology or beyond okay, for the fast charging or rapidly charging, enabling the battery to be rapidly charged. But some of the problems are there associated with, and you have to go through that, and you have to understand equilibrium, uh, reactions, actually, reaction of the far from equilibrium condition, and you have to bring it. Then the remaining technical challenges, actually, those are very much important from the motor point of view, drive system point of view, and battery point of view, and charging point of view. But of course, I didn't come across infrastructure point of view. At least, what is the battery technology? So, drive system technology, battery technology. These two are foremost important technological changes, challenges, technology challenges. One has to think of, one has to take care, and bring in some lot of advancements actually to make large market or penetration of okay, so this plug-in electric vehicles, hybrid electric vehicles market. So material R&D, of course, maybe we are not much concerned, major concern about material R&D, but still you can think of the body weight, so reduced by 35% interior, like seats and all, chassis suspension, right? Reduced weight by 25%. So if you are able to reduce the weight by seeing, okay, torque to weight ratio of our motor or battery weight and all, so then overall reduction of the cost and efficiency, mileage, all those things may improve. Then coming to the second challenge, that's what actually here comes to the second challenge, okay, second category. So this is what actually second category. Okay, one has to see that. So here, okay, vehicle range control, and then locate okay charging station. So these are all infrastructure. That means how to locate the charging station. Apart from the okay charging station infrastructure, how do you locate the vehicle range? That is new infrastructure charging station and real-time information, having the ability to reserve charging stations, because the charging station may accommodate only three or four vehicles. When so many vehicles are coming forward, unlike our conventional fuel vehicles, see whatever number of vehicles, of course, they can accommodate when they do something like that. Okay, but it will take only just a little bit of time, just fraction of minutes, something like that, a few minutes. But unlike the conventional fuel, okay, conventional automotive fleet, okay, so here it's a different type of thing. That's why real-time information, real-time availability, ability to charge or to reserve the charging stations, all okay, and payment methods, okay, will be useful for the okay penetration of the large penetration of electric vehicles market. Right? Locating the charging stations also, that is also important. I'll move on. So here again, voice is breaking or okay? Yeah, yes, and yeah, no questions in the chart. Okay, Subramanian sir and Kamala. No, no questions. I think. Any questions? Let me take. I think half an hour. More than half an hour. So let me take one or two questions. Any questions? If you have any questions, can type, because I am seeing only just the message like okay, nice presentation, good presentation, something like that. Good. Any questions? You can type. Okay. Just in between, I'll go through the okay questions. If you type the questions, maybe will be helpful for interaction. Okay.
Sir,
Because
sir,
in online mode, actually, we could not make it much interactive, but at least let's make it okay to some extent as much as possible interactive to chart. Okay, and then coming to the charging infrastructure of electric vehicles, and actually charging infrastructure as per standards, IEEE standards, and other international standards, automotive standards. So charging level one, AC level one, AC level two, AC level two, DC level one, DC level two, like that. But these charging charging levels are suitable for okay AC level one residential, okay AC level two, okay 2/3 of charging, AC level two maximum, commercial something like that, DC level one, like that. Actually, where charging occurs, okay, one can go through that, and the representative example and the standard and the codes will be there. Actually, standard codes, okay, like building standard codes, okay, charging codes are there. And supply power for AC level 1, 120 volts AC by 20 amperes, 16 amperes continuous. Second level also 16 amperes continuous and 20 amperes, but voltage is 208 by 240 volts AC. And maximum also this one, but current increases, maximum 100 amperes, but 80 amperes is continuous. And DC level 20 amperes to 200 amperes, okay, output power, but it is 20 amperes, and it is 400 amperes DC level 2 commercial. Usually DC for commercial and AC for residential or parking lots. Okay, mostly 5 ml per hour, 1.7 kilowatt, like that. Okay. So this is the charging infrastructure. Then coming to the charging infrastructure challenges, because one has to understand right now what are the standard practice of charging. Those are the standard practices. Level 1, level 2, minimum, level 2, maximum, and DC level 1 and DC level 2. Okay, for residential, for parking in the parking lot, okay, commercial, okay, like that. Even for industrial purpose and all. And then what is the challenge one in charging infrastructure? The challenge one. Okay, one can go through that. So real-time communication. Got real-time communication. Okay. Uh, real-time communication. Then second challenge, independence from landlines and communication security. That's what actually real-time communications. That's what you have to communicate. First of all, you have to communicate to the charging station. Maybe right now charging infrastructure is somewhat okay low, less okay in our country especially, but you need to see the challenge to overcome the challenge of real-time communication with the support of smart grid by adjustment of load or setting, something like that. So this is also one more thing, actually one more point. Okay, by maybe with the support of smart grid load adjustment, so how can we overcome real-time communication? Maybe some advancement you have to bring in. then independence from location, independence from landlines, so remote locations and easy deployment with unified architecture. Then, okay, communication security. So here smart grid may be directly impacted. So financial issues may be linked with the billing of station users. So these are all the challenges we need to overcome. Okay, under this infrastructure challenges, charging infrastructure especially. So third-party interconnections is fourth challenging. Okay, fourth challenge. Third-party interactions. So with other stakeholders, how you are going to allow the partnership, making EV stations taking inputs from smart grid and specific interface to different customers. Interfacing, interface, specific interface. How do you interface to different customers? Okay, that's what. And then so system evaluation. So the infrastructure is being deployed now. Then we don't know what the system will look like in 3 years. Maybe the deployment is also important. You have to deploy. What is how the system is going to evolve the next 5 years, next 3 years? Okay, how it look like? So what is the okay advancements you are bringing in the okay existing charging infrastructure? That's what actually maybe advancing the charging infrastructure, okay, with wireless charging, fast charging, which may enhance which could enhance consumer acceptance of our market penetration of PEVs and increase the potential, okay, offered by the technology presents an opportunity for innovation. In the near term, wireless charging may provide convenience to the PEV, okay, customer or okay driver or vehicle owner, okay, something or user, okay, maybe consumer something. So that's what actually here. So maybe with the help of RS-485, okay, you can communicate with the help of industry gateway to the control center or mobile device of the okay electric vehicle. So field side environment monitoring and okay field side EV charge monitoring. So this is what like advancing the charging infrastructure to some extent. You can make somehow the okay PEV consumer more interesting. So going to that, yeah, which battery is best for electric vehicle? Which type of motors are so there? Of course, different companies or manufacturers are using different motors. Okay, what is Balu M? I think so posted which type of motors are used in UVs. That's what just now I have shown that DC motors are there, AC motors are there, DC motors, and then in between BLDC motors. Okay, you are seeing the DC, but it's not exactly DC, that's just DC motor. Okay, like that. Even for PMSM, even induction motors, Tesla is using three-phase induction motor. Like that, we have got wide variety of okay, almost different types of even electric motor, series motors they are using. So different manufacturers are using different types of motors. Uh, Maybe for their like okay what you call different specifications for different specifications or what you call different range of vehicles, so acceleration range or okay torque range or something like that. Okay, for different range of vehicles, different types of motors they are using. Which battery is best for electric vehicle? So far that's what actually I'm saying, that so far no best battery actually we could able to found. Even manufacturers or industry is looking for best battery. So lot of research is going on the battery. So far lithium ion, that is the youngest technology. Okay, lithium ion, but bringing in some kind of advancements like packing, optimized packing and simplifying the packing. Okay, and bringing some security aspect and material aspect. Okay, like that. So actually, they are doing a lot of research. That is Chandra Singh, I think, was 30%. Which battery is best? I just it is shown already in the previously. So youngest technology in the battery is the lithium ion battery. So maybe that is what actually you have to bring in lithium air or lithium this and that combinations, different combinations to bring in or to reduce the weight, or to reduce the size, or to reduce, or both, or okay, all these features. Okay, that's what. And volume, what is the time taken for battery for fully charged? That's what actually it all depends on. That's what even charging infrastructure and the charging charge controller, charge system you are providing. Okay, that level 1, level 2, level 3, like that it is given already. Okay, how many hours are it will take, okay, to charge, okay, for residential type 1, type 2, type 3, like that. And is fully charged how many kilometers? What is the time for fully charging? Again, we ask that one. I think volume. Okay, what is the charging time for battery for fully charged, and what is the, okay, fully charged how many kilometers? What is the, so if fully charged, actually they are giving wide range of that's what different manufacturers are giving different mileage and different. Okay, if once fully charged, okay, people are giving 50 kilometers to 200 kilometers. Now recently I heard that even 1,000 kilometers. Okay, with fast charging, 1 hour charging, and okay, rapid charging, 1 hour, just only half an hour or something like that, and then 1,000 kilometers, 500 kilometers, and 1,000 kilometers, like that they are giving. Recently, I heard that in one of the uh, faculty development program, okay, one of the expert, okay, presented that just fast charging, just half an hour charging, 500 kilometers, like that. Even a few days back, still I remember, I think in the month of June, okay, in Inaudible newspaper, okay, an article was published. That, okay, so a kind of a new kind of battery packing and battery. So within 30 minutes, it will be fully charged. And, okay, drive at a stretch. Okay, 500 kilometers, something like 1,000 kilometers. So here, grid integration challenges. Maybe next part. This is also one of our major technical issue, or maybe you can say that is technical as well as okay, both actually come under. So technical as well as, okay, infrastructure point. So what I mean to say that both it is comes under both technical and partially technical and partially infra. Okay, grid integration, because it comes grid. The grid operation may be technical, and the grid establishment may be infra. That's what. So here, this is what actually harmonics is one point of thing. I already it is shown that impact of penetration of electric vehicles into smart grid. Okay, so power quality prominent. Okay, the power quality issue is very prominent due to EV integration. Okay, then take a couple of people are- thank you, sir, for clarifying. Yeah, thank you. So here, harmonics is one of the prominent fault issue. Usually, the connection or disconnection of electric vehicles, connection of electric vehicles. What I mean to say, connection of electric vehicles is uncertain. Okay, to the grid. What I mean to say, okay, connection of electric vehicles is that one. Uh, just a couple of it's coming low. Yeah, uncontrolled. Not hands. Even it is not in the hands of electric vehicle owner or driver, something like that. So uncontrolled connection and disconnection of electric vehicle. So grid may be subjected to the electrical grid, or smart grid is subjected to uncontrolled connection and disconnection of EVs, and even number of EVs also is all unknown. Okay, that is what actually one of the reason. Okay, the harmonic voltage and current distortion, one of the reason or one of the cause of harmonic voltage harmonics are okay, harmonics is one of the prominent things. Then second aspect is actually this what, okay, EV interface device will affect the network loading profile, voltage balance. Then phase imbalance, then finally power quality. Of course, all these things come under power quality. Besides the harmonics, that's what power quality issues like intra-harmonics, electromagnetic interference, momentary interference, okay, sags, cells, okay, flicker, notches, and transients, different types of transients, like that. Okay, this one. So that's why you need to bring some advancements, okay, to integrate the okay electric vehicles or plug-in electric vehicles to manage as dispatchable loads, or maybe some controlled connection and disconnection like that. Okay, up and down of electric vehicles, up charge and okay, then disconnecting or something like that. This will allow okay consumers to charge based upon the best available utility rates. So for that, we need to lay down the okay, network for bidirectional power flow to vehicle to grid technologies, so that this will become a set to the grid. Okay, and transformer loading also I told you. So what is transformer loading? What is the risk? The risk is high during peak load hours actually. So if all the people are come back and evening at 6 o'clock or 6 to 8 or 6 to 9, suppose if you connect all the electric vehicles, then usually 6 to 8 or 5 to 8, something like that, more load will be there, household loads. Okay, they will turn on their cooking, cooling, okay, almost all appliances. Nowadays, actually, we are using power electronic appliances. Or in the morning time, suppose 7 o'clock, something like that, washing machines, etc. Okay, lighting load, etc., fan load, cooling load, etc. Along with the okay, that means if you okay connect the electric vehicles during the peak load hours, peak hours, then this is a challenging grid integration issue. So this phenomena may lead to wear and tear of the transformer bushings because of the flattened load efforts, and then okay will enhance the transformer load and sometimes overload. Then because of the overload, decrease the voltage beyond the acceptable limit. And once it appears, the decrease load or voltage balance of the transformer, rest of the things you know very well. That's what actually grid integration challenges. Maybe so I have taken, of course, few questions already. It's almost more than 1 hour, so that okay, almost only just a few issues I have covered. And what capacity of battery needed? That's what actually, if it is 50 kilowatts motor drive, then okay. So as per that 50 kilowatts motor drive, okay, you have to think of. Just I'll show you a presentation. Okay, another thing. I'll share one video. I will share. Okay, I'll share one video so that what is the issue. Just you may not be able to hear the uh, audio, but still, okay, I want to show you the video. So just a couple of minutes only. Can somebody? Is it okay?
Yes, sir. It's fine, sir.
Yeah, yeah. I'll play this. And see that it is charging. Maybe audio is not visible. Audio is not for you. Audio may not come. My audio only come because my audio is connected. A vehicle is getting charged. This is a charging infrastructure.
Sir, video is not displaying, sir. Just dialog box seems open. That's it. Video is disappeared from there.
Video is disappeared.
Yes, sir.
I think it is showing me in the video.
We are able to see only the VLC player outline only, sir.
Okay. Yes.
Dialog box is appearing just.
Yes. I'll show.
Yes, sir. Now it's fine. Can you replay that, sir, from starting?
Yeah, I'll replay.
Okay, sir.
Please tell me whether it is displaying or not. Just again started.
Yes, sir. It's okay, sir. Now it's playing, sir.
Yeah. So this is one getting charging, getting charged. So don't fear. Only take care of technically how to overcome all these type of things. We have to think of. So those who are want to buy electric vehicle, don't be panic. Okay, I'm saying, but this is what actually we have to take care of. So these type of issues, these are all some technical challenges under the charging infrastructure. Maybe because of overcharging or battery heat or something like that. So these type of things, maybe some alert kind of system or some IoT system is required here. Okay, particular driver or owner, okay, the consumer has to receive some message that your vehicle is overcharged or something, it is all battery is getting heated up and getting damaged or something like that. Okay, so these all this type of things. And then once the fire incident takes place, okay, in the case of electric vehicles or some accident takes place, should not go directly, like see normal automotive fleet or some fuel based vehicles, what we do directly will go and we'll open the doors and all directly, right, without any care, something like that, taking care. But should not do like that, unlike okay the fuel vehicles. Okay, you should take care of that. Okay, there may be a very possibility that you will be electrocuted. Okay, because maybe leakage of leak of electric power. Okay, current shock, something like that, shock, maybe shock. Okay, it may be subject to shock. Okay, so those things, and then that's what actually preventive maintenance or maintenance or repair. Okay, infrastructure, you have to develop okay different kind of tools, different kind of systems. Okay, infrastructure, these are all very much important. Then only okay the market or the penetration of PEVs will take place, consumers will come forward. Okay, people are thinking nowadays. Actually. Even myself is thinking from the past 5 years whether to go for electric vehicle or this one like that. I have taken already a vehicle, fuel vehicle. I sold it out and I am thinking. This, 2 years before I sold it out, and I'm thinking, and still I am not that much confident. Okay, whether our system is sufficient, our infrastructure is good. Okay, to maintain the electric vehicle. So like even 2 wheelers also, I'm thinking like that. I think many technical people are also thinking that okay, so how to go for it. I think it may be enough, right, to see that. So this type of problems may, okay, problems are there. Okay, you need to take care of those things. And somebody asked that okay, electric motors and some comparison, and some technical study on this one also, it is there. So powering electric vehicles, electric cars in India. Yeah, this is what actually matters. Uh, is it visible, madam? Srilekha, madam?
Sir,
Is it appearing on the screen?
visible, sir.
Yeah,
Yes, sir. Yes.
various types of motors. Somebody asked
Yes.
that various types of motors. There, of course, I think so. I focused on only different types of challenges. These are the motors. Okay, this is series motor, brushless motor. Okay, permanent PMSM, three-phase induction motors, like that they are. Why this is steam motor, brushless steam motor? Again, in brushless DC motor, two types: outrunner type VLDC motor. This is what outrunner type VLDC motor, VLDC motor. Okay. So in runner type VLDC motor like this. So these are all circuit design like this. Actually, the coupling. Okay, this one, this two-wheeler actually VLDC in runner type, and this is outrunner type. Okay, the outrunner type arrangement is outrunner type arrangement. I think I'm scrolling it down. Yeah, like that. So this is what oriental motor. These are the characteristics supposed to be three-phase induction motor. Tesla Model S is the best example to prove the high performance capability of induction motor compared to its counterpart. I think we have got E2O like that Mahindra Rava three-phase induction motor for its propulsion. So Tata Motors have planned to use induction motors in their cars. Tata Motors are also manufacturing, releasing Nexon, etc. already released. Switch reluctance motors are also being used. Is what? Switch reluctance motor. Like that. Okay. So I'll share. So already some electric cars adoption already done by our BE, Bureau of Energy Efficiency, electric motors. Yeah, technical step. This is what EV components and their manufacturers. Is it visible? I think now might have changed the screen.
Yes, sir, but little bit you have to enlarge the screen for proper visibility.
Sure. I'll make it full view so that full screen mode. It is changed or
Okay, sir.
yeah. These are all EV component manufacturers, maybe all country, and you can see our India also. BHL Motors, their grid chargers, ABB chargers, XCOM chargers. This side, right side. Yeah, BHL, ABB, Delta Electronics India chargers. Yeah, Samsung SDI cells, battery packs, LG chemicals, I think, cells and batteries. Mahindra and Mahindra also focused on this one. Tesla also, I think, in India, they are writing exporting Panasonic cells, battery packs. What to you? Thank you, madam. Thank you, organizing committee. Thank you, Saravanan sir. Thank you, everybody, sir. I think any
Thank you, sir.
questions? Very well, session.
From the
Automatically
participants,
charging. Yeah. Why can't we use some controllers during charging so that automatically charging disconnects? That is what actually we are think of. Actually, all this automation. So because industry 4.0, what is industry 4.0? Fully automation, IoT, AI. Okay, all these new advancements you have to bring into these electric vehicles so that safety, security enhancement, and large penetration. But first of all, battery maintenance, you have to make it come down. So, and this one, the electric drive system, okay, cost, you have to make it come down. So then only the penetration, large penetration will take place. Yeah, madam, carry on. Because
From the participants,
in a
if you
question
have
in
any
chat,
question, please mention in the chat box. Although some of the participants are going to be posting their questions during the session, and sir have clarified all those questions, I thought. Still, if there is any questions,
I think
please.
some YouTube chat box also you are seeing, madam. YouTube, I think.
Sir,
Live
yes, sir.
present.
We are checking in YouTube also, sir.
Yeah, yeah. So any questions are there in YouTube?